Hello everyone, welcome back. In this video, we're going to learn about a second type of conditional statement, the switch statement. So far, we've been watching videos and learning to code up if-else statements and if-else-if-else statements, which are multiple alternative if statements. In this lesson, we're going to learn about switch statements, how to implement them, and why you might choose to use a switch statement over perhaps an if statement. So let's start with our warm-up task. Go ahead and open up a file in gedit called switchfun.cpp and code up an empty main function. Once you get your switchfun.cpp coded up with an empty main function, let's begin our discussion of some of the disadvantages of if statements and why there is an alternative to if statements called switch statements. So one issue with nested if statements, and recall that nested if statements are if statements in the bodies of other if statements or else if statements or else statements, is readability. And we've actually seen an example of this. We've seen in the last video an example where there were a lot of if statements nested and there weren't any curly braces. So it was hard to see which if statements belonged in the body of which other if statements. And as it starts to get deeper in nesting, the indentation starts to get further and further, so it becomes harder to read. These are a few reasons why sometimes it's best to not use an if statement and instead use a switch statement. Switch statements can be used if the nesting is based on the value of a single variable. And that single variable has to be of integer type. We'll talk a little bit more about this here shortly. So if you find yourself having some crazy nesting structures with if statements, you might want to consider using a switch statement. Switch statements can be faster to execute, they can be easier to debug, easier to understand, and easier to maintain. Every switch statement can be written as an if statement, but not every if statement can be written as a switch statement. So often you'll see if statements more common than switch statements, and those programmers who do use switch statements, sometimes it's just programmer preference. But these are some of the reasons why you might find programmers using switch statements. All right, so we're going to motivate a switch statement by doing a little bit of review of our knowledge of if statements. So go ahead and take a moment and read this example here. So we already know how to solve this problem using if statements, and that's the task that I've given down here. So let's go ahead and copy all of this text and then paste it into a block comment in our main function in switchfun. So task 1, go ahead and using if statements, write code that will award the number of points based on an @bat character that you get from the user. So essentially solve this word problem using your knowledge of if statements and user input output. The first thing that we're going to want to do to solve this is declare char to store the @bat symbol. Excuse me. And I'll initialize it to be a lowercase o that represents an out, just by default. And then we'll need an integer to store the number of points. Now we want to prompt the user to enter in the @bat code, and we'll figure out the number of points to assign based on the at-bat code using an if structure. This would be a good time to echo out our at-bat code just to make sure that everything is working properly. So let's save, compile, and test. Awesome, everything looks good so far with our prompting and receiving input from the user. Now we want to code up the solution to the points problem. We'll use an if statement to do this. If at-bat equals s, then points is assigned 1. And I want to comment that since I only have one statement in the body of my if, I don't need to have these curly braces, but I think it's good practice to put them in there. And then we continue on for the rest of the offensive performances. Just for debugging purposes, it might be nice to put an else in here where we display something to the user like unrecognized at-bat code. That way, if something happens where the user enters something other than SD, TH, and O, we'll be able to give them some kind of feedback about why perhaps the points is incorrect or why the program is terminating or crashing or something like that. Hopefully not crashing. So now that we've assigned a value to points, we should probably print out what points is. That way we can give some kind of feedback to our user. Now's a good time to save, compile, and test. Go ahead and make sure you test out all possible branches of your program, SD, T, H, O, and then something other than those 5 characters. Awesome, so far so good. So now before we move on to start our discussion of switch statements, I'm going to give you another task to work on. Go ahead and resolve the above multiple alternative if statement to use nested if statements, so no else ifs. Before we learned about multiple alternative if statements, we could have solved this problem, but multiple alternative if statements are a little more convenient to write, and they're cleaner to write in my opinion. But a good piece of practice would be to convert this multiple alternative if statement into a nested if statement. So go ahead and try that. Run your code again for SDTHO and a value outside of SDTHO and make sure that it still works correctly. All right, I'll quickly go through the solution for task 2, but first I'm going to put this code in a comment block, and I'll be a lazy programmer and I'll paste it. Go ahead and adjust this multiple alternative if statement to make it only use nested if-else statements. All right, here's my alternative, multiple alternative if statement that uses nested conditionals. So I'll save it, compile and run it, and I want to go through and test out all of the different at-bat codes. Awesome, everything looks good. So you can really see in this example why we often want to use multiple alternative if statements over nested if statements, because this can get ugly. Now, we're going to now implement this same solution that we've used a multiple alternative if statement to solve and nested if statements to solve using a switch statement. Let's start talking a little bit about switch statements. Switch statements are an alternative to if statements when the value used to test a Boolean condition is an integer type. There are more integer types than just int. For example, we know that char characters are actually ASCII codes, which are integers. So we could use int or char with switch statements. We could also use unsigned int, short, long. There are more integer types than the ones we've covered in this class. So we can use switch statements with integer types. We can only branch based on values of an integer, variable used to control the switch. So that's a long sentence that really means this one thing you must keep in mind. We cannot use operators for our different Boolean conditions like we would in an if statement. We don't have Boolean conditions with switch statements. We use constants based on this integer control variable in case statements instead of Boolean conditions like we use in if statements. This will make a lot more sense when we see an example. And then lastly, use a break statement to exit a case. have one more thing to add here, but let's code up this so far. So let's go ahead and comment out our multiple alternative if statement and our nested if statement solutions. So switch statements start with the reserved word switch, and then we specify an integer variable inside of parentheses that we're going to switch upon, meaning we're going to conditionally execute some code based on the value of this integer-based variable. Now, in this case, @bat is our integer variable used to control the switch statement. Now we're going to specify one or more case statements with constants in order to execute code conditionally based on @bat, our integer control variable. So our first one is the case S. And though this syntax looks a little funny with this colon here, we start each case with the reserved word case, then we specify our integer value, and then our colon. After our colon, we have one or more statements that form the body of this case. We don't use curly braces, which is strange. Instead of using curly braces, everything after the colon on a case belongs to the case until a break is hit. So now we have our third new reserved word in this video, which is break. Break is used to exit out of a switch structure. Without break, execution falls through to the next case, which is kind of strange behavior. I'll show you an example of this here shortly. So let's add a case for double. And for triple. And for home run. And for out. We're going to leave the unrecognized character code cout statement for a character in @bat that doesn't match S, D, T, H, and O for later. We'll come back to it. So let's save this and let's run it. S, number of points awarded 1. So far so good. D2, T3, H4, and O0. Awesome. So just to recap, a switch statement is based on a control variable which is of integer type. Based on different values that integer may take on, we'll have one or more case statements. A case statement specifies a value, an integer-like value, that if @bat or your control variable matches, will execute all of the lines of code belonging to that case statement, so that would be after the colon, until a break is encountered. Now, I said that a break is used to exit from the switch structure. Without break, execution falls through to the next case. So let's see that in action. Let's say I comment out the break associated with S. Let's see what happens. Now I enter an S and it says number of points awarded is 2, but 2 belongs to the D case. But without the break, even though we have this case D here, it's ignored and code continues to be executed until a break is reached. So if I were to comment out this break as well, then execution would fall through all the way from case S until this break is hit. So we'll see that points 3 is shown. So you definitely don't want to forget your breaks in there. Sometimes this can be helpful. For example, let's say that we want to account for both lowercase and uppercase at-bat characters. Then we could add another case like case capital S and case capital D, so on and so forth. And whether an uppercase or a lowercase s is entered, the same points assignment will occur. We don't have to have a separate points assign 1 and break for this uppercase case S. All right. Now, I said there was one more thing that I wanted added to this list of information about switch statements, and that is something called default. All right, default for switch is like else for if statements. So we can add a default case to the end of our switch structure that will be executed if no other case statements were matched, or if there's no break. So no value on default, just like there's no Boolean condition on else. Putting a break here is optional because default has to be the last case. So you're going to exit the switch structure anyways because there's no other cases afterwards. So I'll put break for default is optional. All right, let's try this. And I get unrecognized character code. However, let's say I forget to put a break in for H and O. Let's see what happens. I get unrecognized character code printed, even though that's part of default, and number of points awarded is 0. Without the break, we'll assign points to 4 to points, and then 0 to points, and then we'll print out unrecognized character code. So I want to emphasize that default is executed if none of the previous case statements evaluate to the value of at-bat or your controlling switch variable, or if you have no break statements and one of these did evaluate to the same value as at-bat. So don't forget your break statements is the moral of the story, because without them, execution falls through regardless of the case label. All right, let's head back over to the notes because we're going to expand our switch example a little bit here. All right, so take a moment and read this variation of the previous example, and then go ahead and modify your original solution to our at-bat problem using an if statement to account for this new modification based on class standing. All right, so I'm going to copy this and move it into our code just because it makes things a little bit easier. If we can read the prompt while we're coding it up. So what we want to do is now also prompt for the class standing code from the user. So we'll need another char. I'll initialize mine to be a freshman. Please enter the class standing. All right. So let's comment out our switch structure. And come back to our if structure that we originally started with. I'm going to copy that, or you can modify yours in place, but I'm going to make a copy of mine and paste it right below our new prompt. So here, when freshmen and sophomores score a home run, they earn an extra point. So right here in the body of our @bat == H, else if, we want to do some kind of test. And we want to see if class standing equals F or class standing equals O, then they get an extra point for home runs. So points gets points plus 1. Or we could just hard code this to 5. But this line 108 here reads more like the comment, extra point. Here's the extra point. That way, if at some point in time the value for home runs changes, we wouldn't have to also change this line of code here. It would be based on just changing this value here. Okay, and then the next one, juniors and seniors do not earn any points for singles. So go ahead and code this up similarly, but juniors and seniors don't get any points for singles. Now is a good time to save, compile, and test. So let's say that we hit a single and we are a junior. Number of points awarded is 0. That is correct. Let's run it again. We hit a single, but this time we're a sophomore. Number of points awarded is 1. Correct. Now let's say we hit a home run, but we are a freshman, then we should get 4 points plus an extra 1 is 5. So awesome. That looks good. Now, let's solve this problem again, but instead of using a multiple alternative if statement for our @bat codes, we'll use a switch statement, just like we did for this solution right here. So go ahead and work on adapting this code to handle the class standing special rules. Just to save a little bit of time in the video, I'm not going to go ahead and code that up, but the solution is here in the notes so you can compare your solution to this one. All that's added here is the if statements for class standing being freshman or sophomore, for singles, getting 1 point, which is similar to what we were doing where we were assigning 0 if this was going to be a junior or a senior. And then down here, 1 extra point for freshmen and sophomores. Otherwise, it's the standard 4 points for a junior or a senior. All right, last set of notes on switch statements, just to kind of wrap up everything we've learned so far. You can only use a controlling variable in a switch statement that is of integer-based type. So you can't use a double or a string variable. Like these two examples here, these would not work. This should be a string in C++, not a string in C. Okay, an arbitrary number of statements can follow a case label. It's always a good idea to define a default case, just like we did with our else when we had our unrecognized character code. It's really helpful for debugging purposes. And then lastly, I said this a few times, and it doesn't hurt to have it in writing and say it one more time. A common mistake is to forget to include a break at the end of your case. If you don't have a break in there, then execution falls through to the next case label, continuing through case labels until a break is hit or the end of the switch structure is hit. So I'll leave this up here for our last example of switch statements in this video.